Right, day 21, part 4. Now we know the big three, product quotient chain. So let's do a couple examples where we need to use all these. All right, so let's first rewrite f of x. Okay, so I have this 5x times x plus 3 all to 1 half. Now I'm going to use the product rule, and then within the product rule, I'm going to have to use the chain rule. So what does the product rule tell me? Hey, it's going to be the derivative of the first, which is 5, times the second. So 5 times x plus 3 to the 1 half. And now we're going to add to that the first times the derivative of the second. So here's where the chain rule comes in. So it's going to be 1 half times, and I should put this all in parentheses or bracket, x plus 3 all to the negative 1 half times the derivative of what was inside. And now we simplify. So all I did in this step was just change negative exponent to a positive exponent. Now I'm going to try to find a common denominator and make it into one fraction. So I found my common denominator was the 2 times x plus 3 to the 1 half. Now when I simplify this, 5 times 2 is 10. X plus 3 to the 1 half times x plus 3 to the 1 half. When we have like bases, the base stays the same when we add exponents, so it's to the first power. And then over here I just have 5x, and now I'm going to distribute and simplify. We get 10x plus 5 is 15x. 10 times 3 is 30. All over 2 times, now 1 half power is going to be the square root, so it's going to be 2 times x plus 3. All right, let's go to the next one. Okay, here I need to take the derivative of sine, and then it'll be the outside will be sine of some angle, which the derivative will just be cosine. But then when I take the derivative of the inside, I'm going to have to use the quotient rule. So let's do that. So the derivative of sine is cosine, and that's the outside part. Leave the inside the same, and now we're going to multiply by the derivative of what that inside function was, which it now becomes the quotient rule. So Hody high, so it's the ho is the denominator, times the derivative of the numerator, minus Heidi ho, so 2x plus 1 times the derivative of the denominator, which is 1, all over ho ho, which will be x minus 3 all squared. Okay, and let's simplify this part. We're not going to, this doesn't end up getting multiplied by the cosine, because that's the argument of the cosine. That's the angle of the cosine. So that kind of stays where it is. And then I just simplify this over here, and let's see what we get. And so the 2x and the negative 2x cancel out. We get negative 6 minus 1 is negative 7. And all I did is treated this like a coefficient. So this whole thing, negative 7 over x minus 3 all squared, and then times the cosine of the angle. Okay? All right, let's go on to the next sheet, next page, and use the chain rule on this rational function. First thing we're going to redo is write it with rational exponents, and now we're going to use the quotient rule. So Hody high minus Heidi ho all over ho ho. And let's do that right now. Okay, so as we said, Hody high, so this right here, the derivative of the numerator is where we use the chain rule. So the 1 half power comes out front. So again, it's the ho, which is the denominator, x minus 3 times the derivative of the numerator, which is 1 half. Keep the inside the same, and then subtract 1 times the derivative of what was inside. And so right now, we're going to have to go through and simplify this, and I'm going to rewrite the numerator. So this is a fraction, and eventually we're going to have to multiply to get a common denominator. We have fraction times a fraction, fraction over a fraction, then we'll multiply by the reciprocal. All right, let me do that now. So this 1 half and this 2 cancel out, and all I did was just write the negative exponent into the denominator using rewriting with a positive exponent. And now I'm going to make this whole numerator one big fraction. So I need to find a common denominator, and that common denominator is going to be 2x plus 5 to the 1 half. So I multiply both the numerator and denominator by that 2x plus 5 to the 1 half. Okay, and what I should see is, hey, over here, 2x plus 1 2x plus 5 to the 1 half times 2x plus 5 to the 1 half, like bases add exponents, going to be to the first power. All right, let's do. So here's my numerator simplified. Again, x minus 3 all over 2x plus 5 to the 1 half. Here's, that was the denominator, so we had common denominators. And then it's minus 2x plus 5. I'm just going to save a step right here. And it was being divided by x minus 3 all squared over 1. So I'm going to multiply by the reciprocal. 1 over x minus 3 squared. And now let's get my final answer. And hopefully if something like this, it might be a little bit different, but hopefully you can at least see how I got there. Now let's do the bottom of this page, and that'll be it for this video, and then we'll just have one more for the last page with the data table. All right, so given the graph of h of x pictured to the right, find the equation of the tangent line to the graph of p of x when p of x equals the square root of h of x when x equals negative 4. Right when I hear tangent line, I'm thinking derivative, because the derivative equals slope of the tangent line. So first thing I'm going to do is rewrite h of x, or p of x, instead of square root of h of x to h of x to the 1 half, and now I'm going to take the derivative. So the derivative, we're going to use the chain rule, 1 half out, leave the inside the same, subtract 1, times the derivative of what the inside was. Okay, and now let's just rewrite this a little bit. So all I did is take the negative exponent, put it on the other side of the fraction bar, and then I rewrote it instead of h of x to 1 half to the square root of h of x. Now what we want to do all this when x equals negative 4. So every place I see an x, I'm going to substitute in negative 4. So we're going to do h of negative 4. That doesn't mean it's square root of negative 4. We're going to find the value of the function when it equals negative 4. And we're also going to find the derivative when it equals negative 4. Again, what's the derivative? Slope of the tangent line. So h of negative 4, that's what's the y value when x is negative 4? Hey, it's 4, so it's 1 over square root of 4, which we have 1 half that was coming down. Square root of 4 is 2, so it's 1 half. And then the slope of the tangent line at x equals negative 4, hey, it's down 1 over 2, so it's negative 1 half. And when I do all that, I get negative 1/8 for my slope of the tangent line. And they asked us to come up with the equation of the tangent line. So hey, I know the tangent line, let's just find p of negative 4, which we just did. That's going to be h of negative 4, which is going to be square root of 4, which is going to be 2. So my point of tangency is negative 4, 2. And we know once I have the point of tangency and the slope of tangent, I can come up with the equation of the line. So it's going to be y minus 2 equals negative 1/8 times x plus 4. Okay, so just from that graph and that little bit of information, I can come up with the equation of the tangent line. All right, that'll be it for part 4. We'll have one more part to do the last page. Chain rule.